Morning and welcome back to lesson 3.2, measures of variation. We're going to learn several things about variation and how our data varies in this chapter. There's going to be two videos, so be looking for the second video. On the first video, we're going to talk about how to find the range of a data set. We're going to learn about what's variance and standard deviation, both with population and sample data. Then the second video will be talking about sample variance and standard deviation for grouped data, how to find the coefficient variation and what that tells us, and then implementing the empirical rule. So let's get started. The range is a measure of distance between the largest and smallest values. It's an actual calculation. So we would take the maximum value and subtract the minimum. We're going to look at developing something called the standard deviation. And the standard deviation is a number that measures at an average how far data values are from the mean. So let's look into a reason why we might want to know this. Let's say we have two samples of scores from two classes. One is the percents that my students scored on their algebra exam, and the other data set is the scores that my students in the stats class scored on their stats exam. So they're listed here. If you go into Canvas and click on the Desmos link, you'll be able to pull up the Desmos for this entire lesson and how I calculated everything to go along with the video. So let's just look at this data on a dot plot. So on a dot plot, we have the algebra scores listed on a number line, smallest to largest here. So here's our lowest scoring student and our highest scoring student. And then here's everybody else in between. And then down below are the scores from my stats students, the lowest scoring student all the way up to the highest scoring student. So you can see that both classes had a low of 60 and a high of 100. So the range from both classes is 100 minus 60, or 40. And then let's calculate the mean from each class. So if you click on my Desmos link or type in the Desmos data yourself, I'm going to share my screen here. And you will see that this is so it's intro to standard deviation, algebra, and stats class data. So if you click on this, I entered the algebra data into X1 and the stats data into X2, into Y1. So X1 and Y1. If you type the mean of X1, we have the mean for the algebra class and then the mean for the stats class. So it looks like they both have a mean, a sample mean of 74. Okay. Let's go back to our notes for a moment here. So both classes have a mean of 74 and they both have a range of 40. So if the mean of two data sets are the same, does that mean the data sets are similar? I don't know, because when I look at the data, they don't look similar to me. Like it looks like the algebra class has the majority of their data is around what would be 74. But if you look at the stats class, they don't look that way. It looks like we've got a lot of data that is far away from the center to all these data points here. So I would say not necessarily. C says if the two data sets are the same, does that mean the data sets are similar? And I would say definitely not, because we can see that up above. You can see up above here that the ranges are from 60 to 100 on both of them is a distance of 40, and they're definitely not similar in nature for the data set. So let's compare the deviation, because we said there's something to this. The algebra class doesn't seem to be deviating from the mean very much, where the stats class does. So let's just look at that. So the definition of deviation of itself is the difference between each observation and the mean. So that says that I'm going to take the observation and subtract the mean, or x minus x bar. So 60 minus 74 is a negative 14. So 100 minus 74 would be 26. And then 61 minus 74 would be a negative 13. Now, we can do this in decimals. We can also do this in decimals so we can see. If we click on a new column here, we can say, we want to take x1, because, oh, I'm doing the stats exam, so it's going to be y1, and I want that to subtract 74. So here are all the deviations for the stats class. So let's go ahead and fill those in on your paper. And then this symbol up right here at the bottom of this column is, it's to sum or to add. So let's go ahead and add the deviations. I'm going to go back to decimals, and I'm going to teach you how to do that in decimals. So I want, also, we've been working a little bit more in decimals, so I'm going to show you some things in decimals while I'm here. Notice this little click that I'm clicking on. It's a folder. You can make a folder by hitting the plus value up here, and this lets you do several things like make a table of data, make a folder. When you make a folder and you click on the arrow and it opens up, you can see this faint line means that everything in the faint line is going to be contained within that folder, which is awesome. Also, I recommend saving a lot, just so any changes you've made are saved. So all these things are in the folder. I want to do some things in this folder. I'm going to go up here and I'm actually going to do something down here at the bottom, and I'm going to show you how to drag it up. So I want to drag this up into there. So when I drag it with my mouse, it goes right into the folder too. But I'm going to show you how I'm going to add up that row. So I'm going to say total. That tells Desmos to add, and I wanted to add the y1 subtracting 74. Oh gosh, it looks like all of my deviations add to 0. That doesn't seem to make sense. Let's go back to our paper for a minute. So all of these deviations add to 0. So that doesn't help me, because that's saying on average they deviate by 0, but that's not true. We could clearly see that the stats exam deviates by more than 0. Let's look at B. It says, what information does the sign of a deviation convey to us? So up here, let's say all the negatives mean the observation were less than a mean. So a negative means the observation. Let's write this down. Less than the mean. And a positive deviation means the observation was more than the mean. So all the deviations that are negative means that the observation was less than the mean, and the positive deviations means the observation was more than the mean. Okay. So C says we want to find average deviation because that would tell us about how far all the scores were from the mean. What is the problem with adding the deviations and dividing by the number there are? So I did add the deviations here. So the sum of the deviations, right here, that's what I did, is I summed up all those deviations, and I'm dividing by n was 0 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 0. So that saying my deviation was 0, which we set up here, was not the case. But it says, what can we do mathematically to fix this? So one thing we do know about math is that I could square each of these deviations because that makes them to be a positive value. So each of these squared for instance, I'm just going to do a few of these so you can see, makes them all go to a positive value. Now they're inflated because I squared them, but they're now at least positive relative to each other. So this is where the calculation of standard deviation comes into play. So I'm going to go back to Desmos to show you. So if I took that and I square those deviations, oops, I went I want to square the deviation. So I want to square the deviations and then total it and divide by the total. I want to divide by the count, the count of y1. That means it will put in a 1. And I'll show you what count of y1 is 10. So that's what we wanted to do. So we wanted to divide by the count of y1. Now, in a sample standard deviation, you have to subtract 1 from the count. And this is just the variance. So we're never going to have to calculate this by hand. No worries. I'm going to take you back to my paper here. We're just developing something. And what we're developing here was we developed what's called the variance. A variance is a measure of how spread out an entire data set is. The symbols are here. For population variance, it's sigma squared, and for sample variance, it's s squared. This symbol is called a sigma in Greek letters. So this is what we just did. Now, the variance has no unit. So you can't really, because it doesn't have any units to it, dollars or inches or anything, or percents from the scores. It's just a calculation. We're going to use the variance to get to what we're going to use for a unit, and that's standard deviation. So the standard deviation is right here. The standard deviation is equal to the square root of the variance. So we're going to take the square root of that whole calculation we just did, and that's going to be our standard deviation. The standard deviation is a more practical measure of how spread out an entire data set is than the variance. In other words, the standard deviation represents the average distance the values in a data set are from the mean. So we're still keeping those deviations in there, but by squaring them takes care of the negatives. And then at the end, after we get the average, we take the square root to get back to our unit. So don't fret. we're going to let Desmos calculate this for us, but instead of doing it by hand. And I will show you the Desmos calculations here in the notes. Now here in your notes, on the next page here in your notes, there should be a description here for finding it in Desmos. So you're going to put your data into a table, and then you're going to type stdev in the column that your data is in for sample data, and you're going to use stdevp in the column for population data. So if we go back to Desmos here, this is what I did when I was doing it by hand. And to get the square root button, if you ever need it, it's down in the menu. And then I can put this calculation inside there. And so there is the standard deviation of my data set of the stat scores. And if I do stdev of y1, because that's where my stat scores are, there's my standard deviation. So this is us doing it by hand, and this is letting Desmos use do it in the background, which is much easier. So this is what I recommend, is using the calculation here. So I'm going to delete this. You will not find this in your Desmos because it's just something I'm developing for you to see. So let's go back to our notes. So let's consider the sample of scores from the stat students again. We're going to look at it just a second. So let's find the population standard deviation, the population variance, the sample standard deviation, and the sample variance. Well, the sample standard deviation we already found. That's F equals 13.89. We just found that in Desmos. Let's go back there. Oh, sorry, it was 13.97. 13.97. Now, that's the sample. Let's do the population variance. The population standard deviation, pardon me, we're going to calculate variance in a minute. Standard deviation is 13.25. Let's just label these. I'm going to put them down here. To show you, we can do a note. So if you press the plus button and say quotes, I want to type something. So sample. Population standard deviations below so that you can see these. When you click on this is what you should see. Now, variance, we have to do a calculation. I'm going to show you here. So, back on our description page in the notes, you will see that the variance is the square of the standard deviation. So if we take the standard deviation and we square it, you can get to the variance. So that's what we're going to have to do, is we're going to take the standard deviation and we're going to square it. I'll show you how to do that right now in Desmos. So you could either copy this and square it. So I'm going to just say what we're doing here. Sample variance. And I'm going to say parentheses, stdev, y1, parentheses, and then I'm going to square it by hitting my shift and 6 key, and a 2 gives me a square. So there is a square of my sample variance, which is the square of 13.97. So it's 195.11. And then I'm going to do the same down here. I'm going to put quotes and say population. SCDEVP of Y1 squared. 175.6. So let's go back to the notes. We've been learning a lot. So there is the population variance, there's a sample variance. It says which variance and standard deviation are more appropriate in a situation. And I would say the sample, because I don't have every stats student score. I just have my class. Now you might say the class is the population, but in this case, I would say every stat student would be the population, and I would be using my class as a sample to describe that population. And so because this is sample data, we're going to say that these are statistics here from part E. Let's just say part E. Now we're going to learn how to interpret the mean and standard deviation. And that should be at the your notes, interpretation. So interpreting the standard deviation. So the standard deviation is a give and take from the mean. It's a measure of give and take. So we're going to describe this. I give on the next page, I give a way to do that. So we're going to describe the mean and standard deviation, and I want you to describe it like this. You're going to say on average and then we're going to talk about the mean and its units is, and then give or take, which is the standard deviation and its units. So we're going to say on average, the stats students scored 74%. So the value is 74. My units in this case are percentage points. So on average, the statistics student scores 74%, give or take. And then the sample standard deviation, that's 13.97 percentage points. So this is very important to do. I'm expecting you to be able to do this in the midterm. So when I say 74% in the units here, that's where I'm describing the mean. So I'm not saying the mean is, I'm saying on average. And then this, I'm saying give or take, and that's in place of saying standard deviation. I don't want you to say the average is and the standard deviation is. I want you to give it to me in a sentence like this. So let's get a little bit more practice. And look at example 3. I want you to take a minute and try to enter this on your own. I do have it in the Desmos link, but it's on a baseball team. The ages of each of the players are as follows. So I enter this data in, use your calculator to find the mean and standard deviation, and then we're going to interpret the mean and standard deviation here. And that will say the baseball students. So here are the baseball players' ages. I put into Desmos, and then I came down and I calculated the mean and the standard deviation. Make sure that you pay attention which column your data is in. So then it renamed it to X2, so I have to use X2 here in my commands. So the mean, I'm going to write them separately in my paper. The mean is 30.68, and the standard deviation is 6.09. And we're going to practice writing this in the context of the situation that's corrected on your paper. So on average, the age of players is 30.68. Make sure you have your units, so that would be years. Give or take 6.09 years.